Hello, this is section 16.3 on electronic computers. What comes to your mind when you think of a computer? What comes to my mind is probably the thing that I'm recording on. I have a MacBook Air 2017 model, and it is a personal computer. But computers weren't always this nice, even though there, of course, are nicer computers out there. Computers had very humble beginnings. You see, a computer is simply something that processes information using an electronic circuit. The information is called data. Now, my grandmother, she was born in the 1940s. She worked for a company that managed computers and switchboards. So you see this quite old picture of people managing some switchboards and managing computers. She was one of those people. Now it's not her, but she was paid to do that. And this computer, the ENIAC, cost roughly $8 million, weighed 30 tons, took up a whole room, and wasn't as functional as a calculator. What? Why would they pay for something like this? The reason was because this computer could do things in less time than humans could do. It could be programmed to do trigonometry, algebra, calculus, and could solve problems, could solve about 5,000 math problems each second, but had to be pre-programmed to do each one. Now, even though your calculator might be better functional than this thing couldn't run any version of Windows. It couldn't do anything. It was a huge undertaking, and it was very, very cool. Now we're going to get back to some more computers in a minute. But we run information in two different ways. Analog and digital information. Now, usually we're pretty used to digital, right? Analog can have any value within a specific range. Let's consider this. The top is 1, the bottom is -1. So if you're right about here, you could be at 0.37584, continue on. But with digital, it can only have a certain range. So this is 0, this is 0.1, 0.2, 0.3, 0.4, etc. A clock is a digital sort of thing. Usually a clock reads only one number, right? It would read 8:52 instead of 8:52 seconds, but let's talk about microseconds. There's such and such a microsecond, and such of smaller than microseconds. Crazy. Computers are digital. They use binary system. They use zeros and ones. 0 and 1 is known as a bit. A group of these is known as a byte. Computers function on a group of 8 zeros and ones. Now, that's kind of strange, and we don't really think like that. But a computer does. You see, think of it like a switch, where if the switch is over here, it's on true or 1. Switch is over here, it's on 0 or false. It's called a logic gate. And these series of zeros and ones, these many zeros and ones, are what makes up everything on a computer. It allows us to run our games, it allows us to record this video, etc. And it requires a lot of components to do so, and it's kind of a unique and interesting process. A computer's physical component is called a hardware. There are lots of things that you have on your computer, if you have a computer, of course, that the computer requires in order to run. Consider the CPU, or Central Processing Unit. And odds are that your computer has one of these, either an Intel chip or maybe an AMD. It's the CPU, the brain. It allows the computer to think, so to speak. Intel Core i7 is a pretty good chip. I have an i5. Some of you might have an i3. But they're all different sizes and abilities ranging in these chips. Not necessarily too much of a size difference. But the single chip containing a CPU is called a microprocessor. Now, to have a chip this small is a pretty new thing. Computers didn't have a chip this small, and this chip, or your textbook says at least, can about double in power every 2 years. That's incredible. Imagine the chips that we have today are probably twice as fast and twice as good as those we had in 2018 and then 2016. I think back to my old Windows Vista computer that we got in like 2007 or something, and how cool I thought that was. But I'd be frustrated if I used that today just because it'd be so slow. But it was a lot faster than I thought that it could be, and that my other computer was. Now, in order to have this massive undertaking of computer language, we had to have a simplified code. And we called that the Unicode standard. It standardized the way that computers use ones and zeros. And so, remember, you have a set of 8 ones and zeros. And the set, if you arrange them in some order, it means something specific. Consider that the number 4 is 00110100. So on my computer, now I can't see this necessarily, but my computer is reading this number 4 that I have typed into this right here. This number 4. Here, I can delete it. 4. And it has to run 00110100 in order to come up with that 4. And every single one of these letters is a string of these 8 numbers. It's kind of incredible. It makes computers sound a lot smarter than it is. So that number 4 takes up 1 byte. And so let's say in this PowerPoint I have 1,000 words. I have 1,000 bytes. That's a kilobyte. And odds are that this, I haven't checked here, but odds are that this PowerPoint, let me look, it takes up a whole lot more than a kilobyte. Here you go. Let's find the properties. Properties. I don't see it. Huh. Strange. Weird. Oh, get info. Here it is. Alright. Sorry, I was looking for properties. This PowerPoint contains, 17 million bytes, which, if you think about it, is about 170 million zeros and ones. That is a lot of data. But considering the size that my computer can hold, it's very little. It's not taking up hardly anything in my computer. And because of that, computers have to hold a lot of data. Computers often allow for a lot of bytes of memory. Most phones have at least 8 gigabytes of storage. That allows for 8 billion codes. And if you think about it, if one of these codes is 8 letters or 8 numbers long, I mean, that's approximately 80 billion numbers that your computer can hold. And of course, photos have numbers too. Because photos, the numbers are controlled by the color, and the photo breaks down each color and each individual part of the color, and it categorizes it with a number, and the whole thing. Very, very cool. So that's why my PowerPoint is so large, because I do have pictures. Creating data. Although zeros and ones are good, what if we want to string data together? Now, potentially, if I knew all the zeros and ones, I could write you a message in zeros and ones. It would take up like the whole board to write a simple message, but I could potentially write you a message. Hello there, class, how are you? But what if we wanted it to run a command? Well, what we need is commands like and, or, and not. Consider this. I click on the next slide. Click. Well, all the computer received was a click, and it said, "Okay, let's get off this slide, and go to the next slide." You know, or it could do a not command. Here's what I want you to do. I want you to bring up a pen. And as I'm writing here, yada 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 yada. If I were to exit out of the PowerPoint, I would get, do you want to save the changes? Exit and save. Exit, but do not save. These are two separate commands that your computer does understand. So that's just kind of an interesting thing that computers can do. And code often looks like this. I mean, this is a very complex code. Yada, 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 yada. And people have to hand type this kind of stuff. Very cool. You can see a lot of statements in there. If this, then do this. If this, then raise this. If this, then return here. And this is computer codes all over the place. And here's where we're going to end today. Storing information in memory. You have two different things, random access memory, read-only memory. Random access memory is the things you need to find information on the computer. So if you want to upgrade your RAM on your computer can think about more things at the same time. It can't hold any more data, but it can think about more things at the same time. So if I want to run this program, and I want to run my my Age of Empires 3 game, right? It needs a lot of memory to do so. Why? Because it needs to run both things at the same time. ROM, read-only memory, is only needed to start up a computer. So if your computer is having problems starting, it's probably an issue with the ROM. And the hard drive is what contains the information. Well, anyway, we have a couple more slides to go. Wow, a little bit more than a couple more slides. But we'll get to those tomorrow. No homework for tonight. The homework is for tomorrow. I'll see you guys later.